Welcome back. This is going to be part 3 in momentum, and we're going to have a little fun with a gun and a piece of wood that is on a track without friction, and the block of wood is standing still, and then the gun fires and the bullet hits the wood, burrows into it, and it becomes a system, and it then has a velocity after the shot of 1.13 meters per second. And the first part of the problem is to calculate the velocity before the impact. So we're going to find how fast the bullet's going beforehand. And I imagine it's pretty fast, but let's see how this goes. What are we going to need? We are going to need to understand that the momentum before has to equal the momentum after of the whole system. The block of wood was standing still, and the bullet was moving pretty fast, then it impacts, and then we have a new situation. We have the after situation. So we will need this. And when we do that, there's only one unknown, and that's the first part of what we're looking for, because we're going to need that in order to calculate part B. All right. So using this and putting everything in, we get something real simple here. I'll let you do the numbers yourself so that you can work it out. Since this is part 3, I'm sure you're a little better at it by now. We get a velocity for the bullet of 142 meters per second. That's pretty fast. And we're going to use that velocity to calculate the second part. We want the energy before and after. In other words, we want the kinetic energy. So what is the kinetic energy of the bullet? Now we can calculate that. What is the kinetic energy of the system when the bullet burrows into the wood and it's moving at 1.13 meters per second then? All right, let's move on. So we know the velocity of the bullet, and from that we can calculate the energy of just the bullet, because the other part's standing still. So this is just about what is the kinetic energy of the bullet. And it has, after you just plug in everything, because you know how to do kinetic energy, mass velocity squared divided by 2, and you see it has 26.2 joules. So not bad for a little thing that weighs just over 2 grams. All right, let's look at the next one then. Now we have the mass of the piece of wood plus the bullet. That's why we have this right here. That's why both are put in there, whereas before we only had the bullet, okay? Because only the bullet was moving first, then it impacts, and they're both moving. And then we were given this, so no problem there. Kinetic energy is kind of easy to calculate. So, all right, we get 0.209 joules, so let's just round that to 0.21 joules. So look at that for a second. Almost all the kinetic energy went into breaking the wood fibers as the bullet penetrated it. And you get leftover heat, you get some sound, you get, and then the rest is what's left, which isn't much at all, hence the very low velocity. But momentum was conserved. Remember that. Both things happen at the same time. The momentum is conserved, and it's transferred to the system, and the kinetic energy is used mostly to break the wood fibers. All right, see you next time.